So this lesson is about reflections, and I wanted to start you with showing you how they work exactly using this Geometr Sketchpad software. So the idea behind a reflection is you're going to have a mirror line, and we're always going to have our mirror lines horizontal. So I think that's the easiest to visualize, because it's like, you know, you're looking at the moon up here, which looks a lot like a circle apparently, and then this is the surface of a lake, and then when you reflect it, when you see the reflection of the moon, you see it down here. And so this would be like, here's the water, and you're looking, there's the moon up in the sky, and here's the reflection of the moon. And we're going to be, so this is going to be like the original shape, and then down here is going to be the image on the other side of the mirror line. And the key to doing them properly, so let's say I have a triangle here and I want to reflect it. When we do them by hand, the key to doing them properly is you take each point like we were before. So maybe this is the point A over here. And when you reflect it, it's going to go to the other side of the mirror line. And the distance from A to the mirror line is going to be the same as the distance from A prime to the mirror line. So the reflection will be on the other side exactly the same distance. This would be A prime here. Another way to think about this is if we were to connect the point, the original point and its image. Let me make this a dotted line. This, since this is horizontal, this will be vertical, it'll be perpendicular to the mirror line, and it cuts this, the mirror line divides this exactly in half. We say that it bisects the line connecting the original to the image point. And we'll use this fact later in this unit, that a reflection, when we reflect a point and connect the original to its image, it's perpendicular to the mirror line, and the mirror line cuts this segment in half. So the distance from here to here is the same as the distance from here to here. And then what you'll do when you're doing it by hand, which we'll do shortly, is you will reflect each point. So I've reflected that point, and we'll reflect one more point. So you'll reflect them point by point, and then you'll connect the dots like you were doing with the other transformations, and this will give you the reflection. One more thing before I show you how to do them by hand. Of course, if something is above the mirror line, when you reflect it, it'll go below. If something is below the mirror line, when you reflect it, it will go above. Get rid of these A and A prime. And if a point's on the mirror line, then it goes nowhere. Things that are on the mirror line, there we go. This point here, which is on the mirror line, when you reflect it, it goes nowhere. And that can be a useful way to figure out if you're doing things right, because if your shape crosses the mirror line, like here's my original shape, that triangle, where it intersects the mirror line, you have these points here, right there and right there. The image triangle should also intersect the mirror line at those 2 points, right there and right there, if you're doing it correctly. So that's a way to check that you're doing things correctly, is if your shape crosses the mirror line, your image should also cross the mirror line at the same place. Another way to check is you should have this pleasing symmetry here. This kind of looks like a butterfly on its side, something like that. So you should have this symmetry when you reflect it. So let's see how to do these by hand. Alright, so let's say I want to give it a mirror line. So let's say this is the mirror line. I'll do 2 examples. And let's say I want to reflect a shape. Maybe this will be, I'll just start with a simple one. I want to reflect this triangle. Now this mirror line here, you can extend this as long as you want. It's an infinitely long line in both directions. So if the shape was not over the mirror line, you could fix it. So my first, I'm going to reflect all three of these points, A, B, C. The first thing I want to do is I want to turn my paper so that the mirror line is roughly horizontal, because it's just far easier to visualize what's going on if you think of, okay, so this is my horizontal mirror line. This is going to reflect downward. It's just easier to track what's going on rather than trying to do it with this slanting line. The way our minds are designed, we find it much easier to see perpendiculars when one is horizontal and the other is vertical. But doing it by hand is pretty straightforward. What we're going to do, let's start with point C here. I'm going to measure how far C is from the line. And what I do is you'll notice that this is tilted. This is not perpendicular here, and you can see that because when it's perpendicular, the tick marks on the ruler will line up with the mirror line. So I'm going to turn this so things look like they line up. So that's pretty good. So that looks to be about 22 millimeters. So then I'm going to go 22 millimeters on the other side. Let me put a little tick mark here so I don't forget where I was. So I'm going to go, this is 22 millimeters here. So I need to do 22 millimeters on the other side. So I'll just slide my ruler down, or maybe I'll turn it around so I can still see the tick marks. So I'll turn my ruler around, and I'll put 22 on the mirror line. I've got to move it here so I can fit it with the camera and everything. That looks pretty good. And so this is 22 millimeters on the other side. So that right there is C prime. Okay. And we just repeat that for each of the three, in this case 3 points because it's a triangle. Again, I'm going to try to keep my mirror line horizontal. The ruler is bumping into the camera, that's why I'm struggling here. So let's see here. So lining things up here, that looks to be about 14 millimeters. So I'll just slide it to my off a little bit. Yeah, about 14 millimeters. So we mark that right there. I'll slide it down. And that's about 14 millimeters there. The tick marks are perpendicular to the line, or lining up with the mirror line, so this is pretty close to being perpendicular. So B prime is here. And then finally A. This is not going to quite, mirror line's not quite long enough to line that up, so let me extend my mirror line a little. There we go. Now let's measure. There's A. So looks like it's pretty much, I can't quite see A. It looks like it's right at the 3, so 30 millimeters. Again, this is lining up with the mirror line, so the ruler is going to be perpendicular like this. And so I need to slide this down 30 millimeters the other side. It looks like it's going to be right off the edge of the page, right there. So that would be A prime. And then I will connect A prime and B prime and C prime. And there's my reflected triangle. And again, if you've done it correctly, you should see symmetry from one side to the other. It should make a symmetric shape. That looks like a pair of eyes. It's like Deadpool's mask or something like that. Let's do another one. So let's say my mirror line looks like this. And now I'm going to complicate things by having the shape pass through the mirror line. So in one sense, it's going to be more complicated. but it makes one thing a little easier. So here's my mirror line again. This is a quadrilateral. It has 4 sides. 1, 2, 3, 4. Fortunately, one of the points that defines a quadrilateral, maybe this is A, is on the mirror line. As I mentioned before, that point, its image is the same as the original. That point doesn't move. So I have to reflect B and C and D. And like I mentioned earlier, this will serve as a checkpoint. My image should be should pass through this point as best as possible. So let's see if I can do this without sliding the ruler around so much. So if I put I'm going to put my 10 mark on the line. There's the 10 right there, right on the line. So if I look at this, this looks to be 10. B looks to be about 14 millimeters up. So I'm going to go 14 millimeters down. Looks like it's going to sort of land on top of the other point. There's B prime, real close to the figure. C is over here. So C is, what is that, 5, 6, it looks like it's about 8 millimeters above the mirror line. Let's line that up more carefully. There we go. I want these to line up with the mirror line. That's somewhere between 8 and 9 millimeters. So I'll come down to around there. That'll be C prime. And then D is over here below, so it's going to go above, lining up the 10 there with the mirror line. Line it up nicely. There we go. So that looks to be, what is that, 10. This ruler is wearing out. I can't see the marks anymore. It's about 18 millimeters. So I'm going to go 18 millimeters up. So there's 5, 6, 7, 8. So D is around here. There's D prime. And then I'll connect A prime to B prime to C prime to D prime, and then back around to A prime. And it looked like things worked out pretty well. My checkpoint worked. The image and the original were supposed to cross there, and they did. And I've got this symmetric looking figure. It's a little bit off, some sloppiness. In particular, I think D prime is a bit off. Looks like it's a little bit too high. It should be lower. So let's look at how we do this in accord with coordinates. This is the point -1, 3, and we're going to reflect it through a line. And there'll be 3 types of lines that you'll have to do. First, you'll have to deal with horizontal lines. So this is a horizontal line. Anytime you see x equals a value, that's a horizontal line. Let me show you why. So let's draw my coordinate grid over here. There we go. So the reason why x equals 4 is horizontal line. So if x is 4, that means I have to be 4 to the right. 1, 2, 3, 4. This doesn't say anything about y. So y could vary. Y could be going up or down. But we have to be 1, 2, 3, 4 to the right. So that means my mirror line is a... Oh wait, I screwed this up, didn't I? Many apologies. I've taught you poorly. It's a vertical line. First mistake I've ever made. X equals 4 is a vertical line. Sorry, anytime you see x equals number, it's vertical. My bad. Caught my own mistake with my own advice. So we're going to reflect -1, 3 through the line x equals 4. So this is a horizontal line over here. -1, 3 is right there. And it's actually very straightforward. We see how far this is from the line. There's my original point. We can just count boxes. 1, 2, 3, 4, 5. Or we could subtract. This is 4, this is -1, so those are 5 units apart. In any case, we know that this is 5 units here. So when we reflect it through this line, it's going to go 1, 2, 3, 4, 5 over to the other side. And notice the only coordinates that changing is the x coordinate. The y coordinate is staying the same because it's just moving horizontally across. So this is also 5 units from the mirror line. And I just need to know what this point's coordinates are to answer the question. The y coordinate is the same. It's still 3. The x coordinate is 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is the point 9, 3. Or you could say, well, this is 10 over, and since this is -1, -1 plus 10 is plus 9. Second type you'll have to be able to do is you'll have to be able to reflect through a horizontal line, and this time I'm going to get it right. Y equals a number is a horizontal line. For the same reasons as above, or perhaps I should say for the analogous reasons. Okay, if I'm y equals -1, that means I have to be down 1. This equation says nothing about x, so x could vary, but I have to be down 1. So that means y equals -1 is a horizontal line, down 1. I've seen many students carelessly get this wrong and flip it around the other way, and it's a silly mistake to make. So x equals a number as a vertical line. Can't see that up there. X equals a number as a vertical line. Y equals a number as a horizontal line. The procedure is the same. I want to reflect 2, 5 through this line, so I plot the point 2, 5. 1, 2, 3, 4, 5. Here it is up here. And I just see how far is this from 6. 6 units from my mirror line. So when I reflect it, it will go 6 units below from the mirror line. 1, 2, 3, 4, 5, 6. And again, you're starting to see the next problem peeking out here. Again, here, only the y-coordinate is changing because the point is moving up and down. The x-coordinate of the image will be the same, so this is still 2. How far is this down from the origin? 1, 2, 3, 4, 5, 6, 7. This is 2 minus 7. Or, if you don't want to do all the counting, you can realize that this is 12 units, 6 plus 6 from the original point, and then 5 minus 12 is -7. So that's another way to do it. Okay. The last type of reflection, let me line this off here. There we go. That I want you to be able to do is through a very special line, and this is important in pre-calculus. We're going to reflect through the line y equals x. So what line is that? Let me draw. You could think y equals mx plus b, but there's a very simple way to understand what this line is. This is the line where the x-coordinate and the y-coordinate are always the same. So it contains 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, and down here as well. So the line y equals x is this diagonal line going up at 45 degrees, going through the origin. This is the line y equals x. This is a very important reflection for pre-calculus, so I'm including this. Principle is the same. I'm going to reflect -1, 5. There's a -1, 5 right there. And here, to see the correct thing, I'm going to turn it on the side, and I'm going to count, but now I'm counting diagonals to see how far from the line. See, if I look here, this is 3 diagonals away from the mirror line. So the image point will be the same distance on the other side. So this is 3 diagonals, and so the image point will also be 3 diagonals. So there's the image original, there's the image. Then if I turn this back, I can see what the coordinates of these points are. 1, 2, 3, 4, 5, minus 1. And you may end up have to count half diagonals on this. For example, if I had to reflect this point, it's 1.5 diagonals away from the mirror line, and so this would be 1.5. So their image would be right there. But it's the same principle. Distance from the mirror line for the original point, distance from the mirror line for the image point should be equal, and it moves perpendicularly to the mirror line.